The next topic we are going to see is about inelastic collision. So already we have seen that what is an inelastic collision? The kinetic energy is not conserved. Okay, so total kinetic energy before collision will not be equal to after collision. Here, consider inelastic or completely inelastic collision. For this, it has a common velocity. Let the bodies of masses m1 and m2 have the initial velocities to be u1 and u2 after perfect inelastic collision. So since it is an inelastic collision, the velocity after collision remains same. So that is v alone. Okay, so before collision the velocities are u1 and u2, and after collision their velocity becomes v. So this is before collision. So it is u1 and u2. After collision the velocities become as v alone. Clear? So when you are writing for the particles of mass m1, initial velocity u1, final velocity is just v. For the particle m2, initial velocity u2 and final velocity is v. When you are writing the linear momentum is what? M into v, is it not? And so m1 into u1, so this is for initial, and final it is m1 into v. Clear? Same way m2 into u2, that is for initial, and m2 into v, that is for final. Okay, so add this, so we get total initial momentum, and add this we get total, this is a final momentum. So total initial and final, they are said to be equal, so we are going to equate this both. So we get m1 u1 plus m2 u2 is equal to m1 plus m2 into v. Here in this, if we need the value of v alone, bring this term down. So we get v is equal to m1 u1 plus m2 v2 divided by m1 plus m2. Okay, so this is about inelastic collision. Clear?